In this question, given that if cos inverse of x square minus y square by x square plus y square is equal to tan inverse of A, you have to prove that dy by dx is simply y by x. So let us do the differentiation. So I won't do the direct differentiation. So first what I do is I'll send this cos inverse onto that side. So in that way, the whole constant will go to the right hand side. So can I say that x square minus y square by x square plus y square is equal to cos of tan inverse A, right? If cos inverse goes onto that side, it becomes cos. So as you can clearly see, this is a constant. The constant might be as complicated as it can get, but in terms of differentiation, the differentiation of a constant is always equal to 0. Now differentiate both sides. Differentiate both sides with respect to x. So what happens is you have x square plus y square whole square and vu dash x square plus y square times the differentiation of this. It is 2x minus 2y dy by dx minus uv dash x square minus y square times the differentiation of the denominator 2x plus 2y dy by dx is equal to the differentiation of the constant is equal to 0. So this gets cross multiplied and this becomes equal to 0. So something minus something is equal to 0 and something has to be equal to something. This implies x square plus y square times, you can take a 2 out and cancel that also. So x minus y dy by dx is equal to x square minus y square times x plus y dy by dx. So you just need to simplify dy by dx from this expression. So what is dy by dx? Let us take all the terms containing dy by dx onto one side. So this implies, so dy by dx times, so let me send dy by dx times onto that side. So y times x square minus y square, y times x square minus y square, and if this term goes onto that side, you get plus y times x square plus y square is equal to, now all the remaining terms onto this side, x times x square plus y square, x times x square plus y square. So this term, if it comes onto this side, you get minus x times x square minus y square. This implies dy by dx times, so y is common, x square minus y square plus x square minus plus x square plus y square. Minus y square plus y square gets cancelled. So you get y times 2x square is equal to, here you can take x as common, x square plus y square minus x square plus y square, you get 2y square. So 1x and 1x gets cancelled, 1y and 1y gets cancelled, 2 and 2 gets cancelled. This implies dy by dx is equal to y by x is the answer. Dy by dx is equal to y by x. That's what you're asked to prove. So hence proved. So now I hope you have understood the concept of implicit differentiation. So in this, the simple thing that you need to remember is, if you differentiate y with respect to x, you get an extra dy by dx with that term. So whenever you divide y square, if you differentiate y square with respect to x, you get 2y and along with it you get dy by dx extra. So if you can remember this small point, implicit differentiation will be quite easy. Now to do this implicit differentiation, you also have a shortcut formula. So before going to next topic, we'll also discuss the shortcut formula and then go to the next topic.